This is the fourth video lesson of the unit matter. Today we're going to talk about chemical and physical properties of matter. So let's go to page 17 in the class packet. Motivation. Predict the physical and chemical change of the following. So here we're given a particle diagram of a compound in the gas state. I want you to figure out what would the physical change and the chemical change particle diagrams look like. So take a moment to do it and resume the video once you complete it. Okay, so for the physical change, I drew this. So this is a phase change from a gas to a solid. And for chemical change, I drew this. So notice I have different substances here. I have a diatomic element and a different compound, right? But notice in both of these cases, the amount of white atoms and black atoms are the same as what you started with. I did not draw anything extra or anything less. So there's a bunch of words I want you to know. First one is reactant. Reactant is what you start with, and product is what you end up with after you do your change. Learning target. At the end of the lesson, I'll be able to define and identify chemical and physical properties and changes. So homework will be a Juno pod. Change. When substances change, their properties change. So let's go over some changes. So physical change, particles move closer or further away. An example will be a phase change. So keep in mind, in a phase change, bonds are not forming or breaking. You still have the same substance, right? But some properties will change. Think of solid, liquid, and gases, right? They have different properties, even though it is the same substance. Chemical change or chemical reaction. Bonds form and break, and because of that, they form new substances. Atoms, right, rearrange to form new substances. In both cases, you'll follow the conservation of mass or atoms. So this is a law. So number of atoms and total mass of the reactant, what you started with, and the product, what you end up with, stays the same. So here's an example. Here we have a compound undergoing chemical change. We have two water molecules becoming two hydrogens and oxygen. So water will be our reactant, and the two hydrogen and oxygen will be our products. Learning check number 1. Which substance cannot be broken down by chemical change? So try to do this yourself, pause the video, and resume once you're done. Okay, so the answer is we're looking for an element because elements cannot be broken down by chemical change. So we have to go to table S and look up which of the following is an element. So we know water is obviously not an element, and glucose, which is sugar, is not an element. Ethanol is not an element, so the best answer is 3. Antimony. So antimony is number 51. Okay, so remember on the regions they try to pick an element that you may not seen before. Okay, so don't get lazy. Look at table S. Learning check. Here I want you to identify if the following is a chemical or physical change. So try this yourself, pause the video, and resume once you're done. Okay, number 1. The rain turned to snow. This is describing a physical change. Number 2. I fried 3 eggs for breakfast. That is a chemical change. Number 3. Ray broke glass on the floor. That is a physical change. The tea kettle hissed and steamed when I made tea. Keyword steam, that is a physical change, a phase change basically. Number 5, after raining, my bike rusted. Keyword rust, that's a chemical change. My banana became rotten. Rotting is a chemical change. We added sugar to coffee. So sugar will dissolve in the coffee. That's a physical change. I bake a chocolate cake for friends. Bake is a chemical change. My paper caught on fire. That is a chemical change. I melt the sand by heating it. Melting is a physical change. Okay, so now we're going to discuss properties of matters. Properties are basically characteristics or attributes of a substance. Basically, what can that substance do, for example. So here are some examples. For example, the color, conductivity, gold can conduct electricity, Aluminum is malleable. Bleach has a distinct odor. Gasoline is flammable. So there's two types of properties, extensive and intensive. Extensive depends on the amount of matter or mass. Intensive is the opposite, do not depend on the amount of matter. So here we have some properties. I want you to organize by extensive and intensive. Okay? So pause the video, try to do it yourself, and resume once you're done. Let's start with volume. Volume is an extensive property because it does depend on the amount of mass you have, right? Because volume is related to density. Melting point is an intensive property. Let's say you have a big ice cube versus a small ice cube. Both will have the same melting point. Density will also be an intensive property. Again, if you compare a big versus a small ice cube, same density. Mass is an extensive property because obviously it does depend on how much mass you have. Boiling point is the same as melting point. Conductivity is also an intensive property, right? It does not depend on the amount of matter you have. Let's say you have a small piece of metal versus a big piece of metal. Both will conduct electricity. Learning check number 2. Which property could be used to identify a compound in the laboratory? Try this yourself, pause the video, and resume once you're done. Okay, so the answer is 4, density. Right? If you know the density of a substance, it can help you identify it, right? Because each substance has a unique density. Density is an intensive property, while the other ones are all extensive, right? So they may not be as useful. Chemical property. It is the ability or potential or inability to form a new different substance. It is only evident during or after a chemical reaction. Notice I bold the word only because this is important. So what does this definition mean? We all know paper is flammable, right? But you will never know that unless you've seen paper burn before. So this property can only be witnessed during a chemical reaction. You can only witness paper flammability, or you can only know paper is flammable if you've seen it. Physical property can be observed or measured without changing the substance or identity. For example, we know gold is yellow, and you can observe it without changing the substance or its identity. Same with melting point. For example, you can measure the melting point of gold without changing it. Learning check number 3. Compared to the physical and chemical properties of the compound N2O, the compound NO2 has what? So try this yourself. Resume the video once you're done. Since they have different structure, they will have different properties, right? One of them has 2 nitrogens, 1 oxygen. The other one is 1 nitrogen, 2 oxygens. So different ratios. So therefore, with different properties, physical and chemical. Learning check number 4. Which statement describes a chemical property of aluminum? So try this yourself. Resume the video once you're done. Okay, so here's the answer. So remember, chemical property can only be observed during a chemical reaction. Which one is describing that? So the key word is react. That is implying a chemical change. Okay, the rest you can observe without changing aluminum. Okay. So here is another learning check. I want you to identify if the following properties are chemical or physical. Try this yourself, pause the video, and resume once you're done. Density is a physical property. Boiling point is also a physical property. Flammability is a chemical property. Melting point is a physical property. Toxicity is a chemical property. Oxidation, think of rusting, that is a chemical property. Solubility is a physical property. Malleability, the ability to be molded, is a physical property. Radioactivity is considered a chemical property. Conductivity is a physical property. So let's look at an example. Iron. So iron has a set amount of physical and chemical properties. When it undergoes a physical change, almost all the properties stays the same. maybe except for the shape, because you mold with the iron. If it undergoes a chemical change, notice that all the properties change, both physical and chemical. Let's do another example. Carbon dioxide has a set amount of properties. When it undergoes a phase change, which is a physical change, it does retain most of its properties, except for the fact it's now a solid instead of a gas. If carbon dioxide goes on a chemical change, for example, it becomes sugar, notice that it's now a different substance, so it therefore has different properties. So here's a concept map summarizing what we covered so far. Properties of matter are these properties determined without changing the identity of a substance. For chemical properties, that is no, because you have to change it, right? If the answer is yes, then it's a physical property. And does the properties depend on the amount of substance? If the answer is no, then it's intensive. If it's yes, then it's extensive. Okay? So this is the last slide. So remember to do the Juniper homework. You can do more practice questions on the next page.